Check the mic. All right. Okay, cool. Where are we? So we're basically producing this texture. So one of the things with these textures here that make up the floor is there is potential for duplicate textures in here if it's exactly the same floor tile. So we need to tackle that. So what I'm going to do is set up a situation with hopefully duplicate textures. Okay, so I think it makes sense possibly to actually delete the room data. And then we will make a new layer. And then we just want, pick one. We'll pick this one. We just want to basically brush it in. And we want to see what texture this generates. So this one, this one, this one, this one, these four are duplicates. So let's load up pics again. And we'll see. If they're there anyway. So it's this when it draws here. So you can see you've got that one, that one, that one, and that one. And that one actually. And that one maybe. So we've got 5 potential duplicate textures. Yeah, you can see them there. So they're all just duplicates. So the goal is to stop that happening. We just want one of them. Okay. So let's swap to a new game level. Our new version. And look for where we're working on the window layer. So we could do it if the alpha mask. There's a couple of places we can spot whether it's duplicated. Well, we had this layer section in. Section index is never used. So it's where we set the submesh index, I think. The submesh index just has to refer to the duplicate submesh index. So how could we do this? So we could give each section a duplicate index back into sections, couldn't we? And then we could say section, then we could actually set the actual section, if it's got a duplicate index, to this duplicate section and then run. It's duplicated if the source RGB and the source RGB, which is a file, is the same as another one, and the contents of the alpha mask are the same. That's actually wrong. No. It's the dest image. So we need basically to look for the duplicate on the dest image, which is in section images. Okay, so what we're going to do is we're going to do image find duplicate. Each image. We might make this actually Alt F image. So the fastest way, I believe, well, the fastest way is to just compare the IDs, but I think because we're actually writing this image out, this dest image out, or this image, the ID won't be updated. So we need to do auto dupe image find duplicate dest image. If there is one, we'll do this. If there's a dupe image, else. We'll do this for now. We'll lot of these things in the else will be needed for both of them, but we'll work it out. Okay, put a breakpoint there. So we basically need to find the duplicate image. So the duplicate is going to be one of the section images. So the fastest way to do this is the image. We need to set the image ID for each one. We don't have set ID though. Set ID. So what happens if we want to be an image view? Possibly we call generate ID. So we're going to call generate ID, right? We say ID is 0. We're going to go if pixels and we have get size bytes. Get size bytes. What's this do? Okay. Auto size is get size bytes. If size, else ID is 0. We'll go ID equals hash 64 of pixels size. I think that's how we would do it. So what we would really want to do is put some kind of generator in here. So it'd be something like template class image ID generator. Like this. And then we would do struct image default image ID generator, and then we're just going to do this. This, and then it's basically this. Like that. So it would be ID is generator this, like this. So what we would do is we would just say dest image generate ID default image ID generator. Of course. Put this right at the bottom. So what's going on here? That's image ID. Return ID. It's actually image view. Okay. Maybe the generator needs to return an image ID actually. Do this. Oops. It's not a constructor for image ID, which is a shame. Find duplicate, right, here we go. So all the test images that go into section images will have IDs. So we just no idea, mate, what that means. How's it going? All right. So we need to go for auto section image in section images. Well, you've got to keep it safe for work. Postokyo, hello, how's it going? Oh. Doing alright. Bit tired today, but we'll get through it. Hope you're alright. Okay, so we're gonna go if section image .id, the ID equals image dot get ID, return section image like that. Yeah. What are you up to today? Anything good? So that will return if there's a duplicate. So let's just test that out. There should be some duplicates in this. Should maybe actually return the duplicate index. Maybe. Oh, we'll see. Yeah, cool. Okay, so that doesn't generate the ID, so it should have an ID, which it does. Find the duplicate. Well, there's no section images, so we add it in. We do the next one, So there should be some duplicates. No, we didn't actually find any. What's going on there then? Oops. So it is generating a different. It should be generating the same ID for every single duplicate. So see why that's not happening. Almost certainly when the pixels have values in. So we might actually need to save out these images to know which one we're looking at. It would be nice to have like a debug view of an image. What's it hashing there? It's hashing the wrong thing, that's what's going on. So we have actually a hasher for images. So I think we could theoretically hash 64 the image. How is this hashing it then? It's hashing them one row at a time. For some reason. I think that's... I don't know if that's actually correct, that hash. So a view doesn't have to be an entire image, it can be a section of an image, like a rectangle inside an image. Ooh. So that's why it's going down and just doing one row at a time. But is that still not correct? Unless so. Oh, we're doing pitch. Yeah, I think that is actually correct. Depends if the pixels for a view start at the top left corner of the view or at the top left corner of the image. They must start at the top left corner of the view. Yeah, because it's adding on pitch. Pitch will be the pitch of the entire image. Yes, I think that is correct. Let's try that again then. Slightly slower way of hashing, but it's fine. Okay, do we detect duplicates now? Yes, we do. Okay, so what happens if it's a duplicate? We still need to add in the sprite, but we need to give it a different submesh index. We need to give it the submesh index of the duplicate. And we don't need to append tile range indices in there. Because it's going to be the tile range indices of the duplicate as well. So we need to like track that somehow. So the window layer has tile range indices. So it probably needs to return the section index as well. So we're going to say, rather than find duplicate with that, we're going to say standard optional size T. Whoops. And this is just going to be do this, and we'll just return S, otherwise we'll return that. So that's the duplicate index now. So the sprite index, so we need to do, so the tile range index. Oh, checker, how's it going? Hope you're alright today. I'm just continuing to work on this content pipeline stuff today. Working on moving the compiler to OCaml. Oh, brilliant. Yeah. Awesome. That's fun, that. So is it compiled? Like, is it a compiled language? Like a native systems language? Like C++ or something? Not really heard of it before. Okay. Cool. Cool. So the tile range index is window layer tile range indices duplicate index. Let's just check. So that's the tile range of the duplicate, or the tile range index of the duplicate, which is 7. Okay, my garble collected, I guess. Yeah, probably. Yeah, maybe. Yeah, okay. Ah, yeah, cool. Okay. Rust Python. Awesome. I've not even heard of Rust Python or even C Python before. I can kind of guess what it is. Ah, right. It's just the Python. I see. Okay. Cool. Cool. Specific language made in Rust. Ah, right. Okay. Rust Python. So it's Python written in Rust. Awesome. Awesome. Yeah, that sounds fun, eh? You're doing like a ghost, yeah. So it's the way I have my my green screen's so bad that I kind of have to fade a little bit, fade out myself to blend out the background a bit more. But it makes me look like some kind of wizard as well, which I don't mind, to be fair. Good for Halloween, I guess. So the submesh index. Okay. So we need to find the submesh index. Basically, because that's what we need to hook up. We need to find the submesh index. So we need to go through the sprites. Okay, so the sprite index is this. So I'll put sprites out here. And then we'll say the submesh index sprites sprite index submesh index. The living undead. Yeah. When I have a big beard going, I do look quite wizardy, which is nice. I'm a big fan of giant beards on wizards. I'm much more of a wizard with a staff rather than a schoolboy with a wand. So that's the submesh index of the duplicate. believe. She's also 7. They're all 7 at the moment. Have I seen Punky Doodles? No, I haven't, no. No, not heard of him. Cool. So that's the submesh index of the duplicate. So we need to do this. Add the sprite in, and then we say submesh index. Oh, this is the dupe sprite index. And that's the sprite index. So the submesh index is the sprites, the dupe sprite index, submesh index. We do this as well. Felix in leg, how's it going? What's going on here? What's going on? So I'm working on the game engine content pipeline right now. So I have a level editor. I'll show you. I have a level editor. It might not work actually with all this in it. Let me just. A level editor which makes levels, and that's saved as like a text file. But then when you want the levels to be compiled into game data, they need to go through a process where they create the text file. Not everything that can, the level could be in a level is in there, and then it gets compiled down to game data. So right now I'm working on. So this is like a floor or something. And this is what's generated at the end. So this is the level editor that I made the floor with. And it builds meshes and puts bounding boxes in and stuff. But right now, like if you look at this tile and this tile, this tile, this tile, this tile, they're all the same asset. They're identical to each other. So I'm going through kind of spotting this duplication, like a process, so I can spot this duplication when the compiler is happening, when I'm compiling the game data down, and then everything can just reference the first one instead of making, new meshes and stuff for all of this. Like a resource manager. Yeah, it's kind of its process is to take the text. So I'll load up more of a complicated okay. So there's all sorts of different data in here. All sorts of different types of content. So this thing is a trigger. Then you've got like sprites, and you've got ponds, and you've got rivers and paths and animated characters and explosions and cloth and particle systems. So all these leaves are particle systems, and that just exists as a text file for the level editor. But there's stuff in this text file that the level editor needs that the game doesn't need, and it's text, so it's slow to load and parse and stuff by the game. I want it as text for the level editor so I can actually go in and edit the text directly if I want to. But there needs to be a process of turning that text file into binary data, so you have like a data package that the game can load, which is just binary data, and it's all kind of like streamlined and laid out in a way that's fast to load and to render and everything. It cuts out all the stuff that just the editor needs and the game doesn't need. And then the game itself loads that binary package. So this is all game data, which is like literally just binary data. Come on. Windows Explorer's crashed. Awesome. Don't know what's going on there. Try that again. I've had a few like bugs with Windows 11 really, a few crashy things. So that's just binary data. And that's once it's been through the process, and then the actual game itself loads that. But yeah, right now there's those duplicates that I'm trying to spot. So when the compilation process happens, we can spot these duplicates. That's a lot of text, yeah. So the text is good for me on this computer, making the game with the editor. But obviously, it would take quite a long time, relatively speaking, for the game to pass all that. And it's unneeded really, because there's lots of stuff in there like, do you want to show triggers? Or do you not want to show triggers, which is a level editor thing really. So yeah, it will just compile into binary, and then also like the assets, like the it's a space for somewhere like, so you have like, the editor uses PSD files, so Photoshop files for like art. So if I load this more complicated one up again. So like the cloth, for example, if I open the sprite up, you can see it's a PSD file. So the editor just integrates directly with PSD files. So if I change something in Photoshop, it just updates in here. But then obviously like the texture when it's in the game it can't be a PSD file. So that's a space for me to like change texture formats and stuff as well here in the actual content pipeline. Or sounds, like sounds can't really be WAV files because they're too big. So it gives me a chance. This is where they would get compressed to something like an OGG file or something like that. Or like, you know, loads of stuff. Anything that you want the game, you want to turn into game data can happen here. So that's what I've been working on. Yeah, I did, yeah. There's a few things it can do. So it can extract the actual image, the rasterized image. It can extract each layer as a separate image. It can do things like find paths that you would draw in Photoshop and then do effects with the paths. So say like you wanted, so the one I've got that I use in the game is lightning bolt. So you can draw like a path of like the lightning. So it could come in forks or something. And then the level compiler will look at the paths and then create like an alpha from 0 to 1 down the paths. And then when I like load that up in the game, it can like ratchet up the intensity by the alpha, and it creates like light traveling down a path. I can't show that at the moment because the game, like, it's just no, like the engine right now is been taken apart a little bit to do this. And it can also load, do all sorts of stuff like the lighting's generated from Photoshop. So the light here, so that comes from Photoshop. So what I do in Photoshop, well, the light's not come from Photoshop, but what I do is just draw something. So it could be anything, it's just a triangle at this point. And then if the layer has got, that says light 0. So if I call the layer like, it has the word light in it, and then in the editor, I generate lighting, it will pick out those layers and it will light just those layers. Do you know what I mean? Because the idea is, because it's going to be quite a sci-fi game that I'm going to make, it's going to be, I mean, I can do like neon signs and stuff like that that are all lit up. Like this one, you see, that's just me writing light with a font in Photoshop, you see. Then it's lit. And these are like cast shadows and reflections and stuff. So that's why I like to work with Photoshop. So then I can, like, you know, if I change it in Photoshop, it just updates in here. But obviously that also needs to get compiled down into game data. XFC file header. Ah, right, okay, yeah. XCF. Still have to make your own editor. Yeah, I mean, it depends what you want to do. Like, I enjoy making the tech itself. Probably even more than making the game, you know. I like making the tech. So I spend a lot of time with tech. But yeah, it's very boring at the moment. So this is just a floor. So these get like painted in. But yeah, like, they do generate duplicates because they're divided into 256 by 256 tiles. 256 pixel tiles. So yeah, I'm spotting the duplicates. So like this. So what I need to do is like find the duplicate and then hook the new sprite up with the duplicates data rather than add more data into the mesh generator and stuff. F# takes a lot from OCaml. F#, man. Yeah, you've mentioned F# as well. Are you a fan of functional programming? You like that idea? It's very mathematically precise, isn't it? Mathematicians like it, I've noticed. Yeah. Cool. I've only done a little bit. I did a bit of Haskell at university. Took a functional programming course in Haskell. This was a long time ago. It's like 20 years ago. That's really my only... I've seen a few videos where functional programmers make the case for bringing some of their ideas into more systems, procedural languages, you know. There's lean for textual, APL for symbolic. Ah, right, okay. Yeah, Felix, if you've got any questions, just ask about it, no problem. I'll try and answer as best I can. So what we need to actually rerun the... So if I change the game level version, it reruns the level compiler. I don't have a way at the moment to always run it. Maybe I should do that. Maybe I should do something like that, because it's quite annoying having to change the version. This will run if the text file changes, but obviously while I'm building it out, I want it to run all the time, not just when the text file changes. So it's found this duplicate. So it's made this image up here, and then it's found it that there's something else that's the same image. So we get the duplicate. So we get the duplicate tile range index. So that's to do with mesh generation. And the duplicate sprite. So that's the sprite that duplicates it. So we want to move this, and then what we want to do is we want to set the submesh index, which is like a submesh is a part of a mesh. Because obviously a big mesh gets generated for the level, and if you want to draw something in a level, you draw out of that mesh from there to there in the mesh. And you just use and that's a submesh. So it needs to be the duplicate sprite submesh because it's the same mesh. Specific keyboard with actual math symbols, really? Interesting. You'd have to use like Unicode shortcuts or something. Or some kind of have you heard of LaTeX before? It's like a language for writing out maths equations and stuff on a computer. So we've hooked up 7, which is the duplicate sprite submesh index. So tile range indices. So the question is, do we want to add this sprite back in to the window layer? Probably. So it would be like window layer, sprite indices dot add sprite index, window layer tile range indices dot add. It's the duplicate tile range index. Question is, what is this gonna do? I think that's it. Section bounds. See, I wonder if all these just need to be because this is like a structure of an array type thing. We'll try and get away with not doing that. Don't know if this is how this is gonna confuse it later down the line. We'll have to see. Use ASCII keyboard. Yeah. Yeah, you'd have to write a little program that would have a, you could, I don't know, click on the thing on the screen and it would type it out for you. So we've got 2 7s there. All right. So what I'm going to do is go back. Where are we? We want to add in the images in now. So section images 17. These contain no duplicates. Tile range indices. So there's 22 there. So we don't actually have to add in the tile range indices either. have to go slow on this because I'm tired today. So we've got 22 sprites. It picked out quite a lot of duplicates. That's more than I was expecting. Image section 17. Okay. So that should be fine. Okay, so we're going to have sprite indices, submeshes. So this is where we could get into some trouble. So if you get through here, tile range indices. So there's only 17 tile range indices, and there are 22 sprite indices because some are duplicated. So this is where we need to sort it out. So I think it's just, rather than going over sprite indices, we go over tile range indices. And that might work. So we need we need a separate list of sprite indices. That aren't duplicates. Or we just don't add sprite indices in there. Maybe we don't add the sprite indices in there. Maybe that's all it is. This will run now. So this generates the actual mesh for the sprite. Right. So that renders fine. So we'll just open up Pix and we will see. We'll have a look at the texture that it generated. See if there's any duplicates. Right, if we go to wireframe mode. So that's the mesh it generated. You can see all that. That's the wireframe for it. So what it also did, it cuts out a lot of white space, this asset compiler. So if you look at the texture, yeah, we can see there's no duplicates there. That's awesome. So that's worked. That's currently worked. Currently working. Is there a way to... So all we have to do to turn off the duplicate stuff... Nice, yeah. So if we do false ands like this... run it. So this is not testing for duplicates. So let's just fix that. You can see there it's got that's a duplicate. I mean, you can't divide it into 256 by 256 tiles, but you can see there's one there, there's one there, there's one there, there's one there, and there. Maybe there as well. So it saved a lot of space. This texture size is I don't know how you find that out. Info. 1536 by 568 pixels. But without the duplicates it was a lot smaller. Oh, yeah, so I mean, that deserves a celebration. Cup of coffee, I think. And then we need to test it with some other types of content as well. Check all that still works. Because the way that this works is that there's only really one big mesh made for the entire level, at least for a lot of the different types of content in the level, and then you draw out of a subsection of that mesh. So it is kind of all a little bit integrated with the other things that aren't these floors as well. What's going on here? I haven't started analysis yet. Alright. Yeah, so that's only 768. That's good. So yeah, the content pipeline bit as well does what generates. I call them tile books in the engine, but they're like stacked tile sheets. So this is a tile sheet. So this is like one page of a tile book. And I think they automatically expand to 4K textures. So if we add more stuff into the level, it just gets added onto this this texture, and then once it gets to 4K, it puts another tile sheet on it, another page in the book. Alright, so we'll have a quick... Well, I'll check in first. And then we'll add some more things into the level and check it still works. Particularly what I want to do is add different types of floor on top. So what it also does is it merges them together. If I do this, we've got 3 different types of floor, which means overdraw of 3. So you're going to draw this, and then this, and then this. But what the actual compiler does is it merges them together, so there's no overdraw. So I just want to check that. So first we'll just run it and check that it still works. With new types of flooring. Okay, good. And then we'll fix that. So if you see, like, even though there's overdraw and everything, there was overdraw in the editor. There's no overdraw in the game. Because the number one performance killer of games is overdraw, believe it or not. So we look at the actual. So you see how it's merged them together there. So they're not separate textures anymore, even though they came from different brushes in the editor. And there should be no duplicates. It is a bit hard to see because it's a tiled texture. I wish you could break it up into 256 by 256 tiles. That would be nice. UV Atlas. Don't really know what that is. You know, like in Photoshop, you can put guides on. Don't know if you can do that in Pix. Oh, yeah, you can. Look at that. How did I do that then? Don't know how it worked that out. That's really clever. Oh, it's mapping the mesh on top, maybe. Literally, that's clever. And you'll see there's a little bit of padding. You need to do that for... This would have been... When I was writing the system to generate these tile sheets, right, this would have been so handy to know about this. So, like, the pixels in the image, in the tile, the borders are clone of the last columns or rows in the pixel in the actual tile. You need to do that to get rid of some, like, sampling errors. Yeah, you can actually see the mesh underneath that is generated. That's really cool. Okay, that's good celebration. So I'm going to make a cup of coffee. I'll be back in 2 minutes. Yeah, back with more massive coffees. So we'll just do a quick test and we'll put more content. Put more different types of content in. Well, we'll probably be using that in a second. We'll close it. So I want to so we've got some Z things there. That's only because I didn't draw the floor low enough. So it's actually, rather than being on the floor, it's like fences. It's like stacked fences. That's fine. And then we'll draw the cloth. So again, we have that is a Z bug. That the Z should come in exactly the same as the preview brush, so we could maybe fix that. To figure out kind of what's going on with that. And then the other one we've got supported is framed animations. Okay. See if this breaks. So Z is different. I'm not too concerned about Z. What I'll do, so to change the Z of the floor, I believe we select the floor, go to brush, and then we'll say the Z bias is like minus 10,000. And if we just paint, it should put the Z to minus 10,000. The reason why the colour is a little bit different as well is because there's like time of day effect in the game, which alters the colours of the pixels, but there's not that in the editor. All there is, but it's set to like midday, where this is like 7 in the morning in the game. Okay, that was good to me. So let's just, there shouldn't be duplicates for these, but we'll see. Builders next door, unfortunately. So there might be a few bangs. I think they're fitting a carpet. New neighbours moving in. Interesting. So I just want to look at how this gets drawn. So I believe it is a separate shader for cloth. So we get the floor, and we get all of the flags, and then we get a mixture of explosion and the other tiles. What I don't want to see is duplicates. How did this work before? How did I do this before? 28. It worked to get the mesh up, but I can't remember what I did. Text cord. Kind of worked that time, not entirely. Anyway, there is no duplicates there, I don't think. Flags in once. that little tomb thing is in once. And there are all the different frames for the explosion. Okay, that's good. Can move on, I think. So next thing I want to work on is you can paint grass into the game as well. So we will do that. We'll work on some grass stuff. So if I just delete everything in the room file, it will come back as a blank room. Right, so let's add a new layer called grass. So you can paint grass in. So we'll select one. There we go. So what I might not do there, I might just do it right in the middle. Just so I know and I'm getting the position right and stuff. Or maybe actually I kind of want to be able to see the crosshairs, so maybe just above that. Okay, so if we launch this game now, there's nothing there because we haven't programmed how this is going to end up in the game yet. So how do we do this? So we want level data generator. So we make these little structures which just specialize on the type of data it is. Grass content data. So if the level generator sees some grass, it sends it into here to get handled, basically. So just put a breakpoint there and check that works. So this instance is grass content data, and it has some grasses, and the grass has cells in it, and the cells are the position of every grass blade. So I think the way that the grass works is it has some properties, and then you just pass in point array to the GPU. And based on the properties, the grass mesh is built on the GPU, so it's not built here. So it does need a different vertex array. So we've got level grass vertex, which is that. So it's the UV coordinates, width and the height and the texture index. So they're not actually, are they sprites? Are they individual sprites? That's the question. Sprite type. Grass. Maybe are individual sprites. So what I'm doing here is replacing an old system as well, which was really just thrown together to get things to render while I was making gameplay code. So now we're going back, rebuilding out this system properly. But it means I can use the old system as reference. Boom and cheer, how's it going? Morning. Hope you're alright this morning. Hope you had a productive day yesterday. I didn't see you after your meeting. Did it go alright? So we say, in the old system, we say if it's grass. So it is quite straightforward. We have a separate grass vertices array. Okay. But they are sprites. More meetings. Yeah, I was gone, yeah. I had to finish a town a little bit early, actually, yesterday. My car was in the garage. That's all sorted now. Today I'll be on till about 3. If I can cope with the fitting a carpet next door so I can hear them hammering the carpet under the skirting board. Unfortunately. But it shouldn't take them too long. Right. So it's a submesh index range, but into a different vertex buffer. Okay, so it is 1 sprite per instance of grass, which is good. So let's just look at the normal one. See, append sprite. We'll try and send it through the normal one. See what happens. So, what would it be? Level data generator. Normal sprite content data. Instance offset. Oh no, it's not that. It's end sprite. eSprite type is grass. eSprite kind. So we have different types of grass here. I don't know if we actually pass that through, you know. Grass content data, sprite sheet grass. So we don't actually have what type of grass it is. I'll have to work on that. So the kind, I'm not sure. We'll say normal. Intelligence is given up for me. Instance offset zbias room ID context. So that's just the rest of it. It's just this. Oops. Let's just see what happens. The brush data path. Some kind of DDS file. So that is the actual grass texture. Right, so we do need to pass in the segment index here. So what does this return? That returns void. This should actually return the index. Or the standard optional of the index. then I can get it back out again. So auto sprite index is that this sprite index. I'm going to go sprites equals context level sprites, and then we want to go sprites sprite index segment count is equal to some segment count. If you don't know what it is. So there's actually also multiple grasses as well. So get data, grass content data. So if there's no grass content, turn. So grass content has in it multiple grasses actually, which would be multiple sprites. So the grass has in it segment count, hopefully. Right, so let's have a quick look. So this is adding in the actual sprite into the level data. So there's one sprite, it's type grass. The kind needs to be the kind of grass it is, which we can't get yet. It should come in. I absolutely love coding when there's loads of banging going on. It should come in here. We should actually know about the kind here. I'll have to work on that. Segment count 3. Alright, so that's it. That generated the grass sprite. So what we need now is the texture generator. So we need to actually add the texture into the tile book. The grass. We'll copy normal because it's more like normal. Texture generator for normal. To be fair, I think it's basically the same as cloth. I think it just goes through the normal path. So we'll check it anyway. Alright, so now I just need the mesh generator. So one of the things that we need to have a look at as well is that when we're actually appending the tile set, This is going to break the actual grass texture up into a mesh. I'm not sure we want to do that with grass because we're actually building the mesh. On the GPU. Have a look, see if there's just a normal generator. Image tile. What does image tile do? No idea. Try that one though. So we'll rather than splitting the images into tiles, we'll do the image tile version of this, which I think just keeps it as one tile. Where is it? Just that. Right, so try that. Not one, so it's just one tile. Basically. Nuke Bird, how's it going? Hope you're alright today. Working on content pipeline stuff. Okay, cool. What are you working on today? Anything good? So now we need the mesh generator. Mesh generator. So I might just copy this and change it as we go. We do need to generate different vertices because the vertices, we're just saying level.get vertices. We've got a different vertex buffer though. So this is get grass vertices. So they have a different layout. So what is a grass vertex? Got 2 UV coordinates. I know that. So it's got 4 floats of UV, width, height in world. And a texture index. And the position is... So how does it work out what position it is? Sprite? It just passes in the sprite position. How is this? How does that work? Oh, really? Uncle and godfather. Oh, congratulations on that. Nice. Yeah, okay. So is it like an army kind of scholarship thing? So how am I actually building the grass vertices? Position. I don't know. I don't really understand how that's working. There's no position in the grass vertex. I mean, there is in the renderer, it puts one in. But isn't it the same for every... Isn't it the same for every sprite? The sprite holds many vertices and many grass vertices. Ah, yeah. Okay. Yeah. We're gonna have to look at how we did this before. So every blade gets a sprite. Every blade gets a sprite. Is that actually how we want to do that? That seems excessive. Every single grass blade is an independent sprite. I think what I actually maybe want to do, again, like we do with the floors, is have a sprite which is like an area of the map. Because what I want to be able to do is cull them. If we're not drawing them, if we're not on the screen, I want to cull it. This is going to require quite a bit of change. So what that means then is the level data generator. Where is it? The level data generator for grass. It needs a sprite for every... basically 256 area. Anyways, back to coding, Nukebird. What do you think about coroutines? Do you find them useful? Perfectly solvable no matter. I've not found a use case yet for it. Not particularly tried to look, actually. So I'm not sure. I'm not sure on them. They seem excessively complicated in C++. That's what I know. So, yeah, I mean, I might have an afternoon exploring them. The thing is, I can't see any use case, but that's probably because I don't have any experience with it. So, if I spend an afternoon implementing one, then maybe I would start to see use cases. It's difficult for me to see them though, at least in what I do. Maybe some kind of gameplay. They're used a lot in Unity out there. I've seen people use them in C# a lot. Yeah, exactly. Yeah. The thing with C++ is you need to. It's not just a syntactic understanding you need. You need to understand actually how it works to see how you want to use it. Like, how is it saving the stack? You know, the call stack and all that, and the state. How is that happening? You need to investigate all that. Can you do it different ways? So I think what actually happens is it does one malloc when you create the coroutine, and then it uses that kind of area to copy in and out the state. What happens if you don't want to use malloc? How does all this work? You know, it's quite, you have to put a bit of time into understanding it rather than just use it. But yeah, I'll have a look at it sometime when I have time. Right, so I think what I want to do is for every grass, let's go here and see what we have. I want to do a sprite for 256 by 256 area of the screen. Or 8 by 8 in world space. What have I done there? Let's write our own compiler to really understand that. Yeah, I mean, you at least need to understand like the memory allocation pattern of a coroutine, I think. What you don't want is it to be like sugar, syntactic sugar, or magic. You don't want it to be magic because then you don't have control. You don't know when it is best to use it if you don't really know how it works. Okay. So does the grass have bounds in it? It does, and it's in world space, which is good. So what we need to do is we need to actually floor this. So we need to do auto bounds is the grass bounds. We need to do bounds.xy is equal to round down. Does it work with vectors? How do you round down a vector? Bounds.x by 8. But now we'll just hardcode 8. And then maybe we'll do it a different way. Maybe we'll go bounding rect bb, and we'll say bb dot x min. We'll round down x min by 8, and then we'll do y min. And then we want to round up y max check that these routines actually work. Okay, they've got to be floats. So what I might do is cache out tile size. Do you invite your own Vec 2, 3, 4? I wrote my own one, yeah. There's no 3. I didn't write a Vec 3. Vec 2 is the most fleshed out. There might be a Vec 4. Yeah, there is a Vec 4 as well. Yeah, I wrote my own one, yeah. It's not anything flash. It's not got any SIMD or anything in it. So it should be -8, 8, 8, 24 or something. 0 to -8, 8, 0, 24. That's correct. Alright, so now I need to go through this. Yeah, exactly, yeah. There's not enough maths going on in this, I don't think. Not enough vector maths going on in this to warrant SIMD, really. The only bit that might speed it up is, so currently the rigs, the animated rigs, are, so the bones are being transformed on the CPU right now. So that might benefit. And the reason they're being transformed on the CPU is because it's a library. It's not, I haven't written it. So I have extended the library before to do the transforms on the GPU. So that might be something we do if the rigs get too slow when they're transforming. Maybe. We'll either SIMD the transform or we will move it all to the GPU. But later. Yeah, later. Depends how many rigs we have in the game and stuff. Usually, like, on a AAA anyway, AAA game, it'll all get done on the GPU. But their rigs are, like, massively more complicated, so it makes sense. And they're in 3D. You know, this is only 2D, so SIMD's not really going to help as much. Unless you could you could, like, pack... You could do 2 at once, maybe. You could have 2 Vec 2s in a SIMD register. Okay, cool. So what we want to do is we want to go for auto. Y is equal to bb dot y min. Y is less than bb dot y max. Y plus equals tile size. Same for x. So now we have the box, which is x, y, tile size, tile size. So that's the box in world space that we want to make our sprite with. But what we want to do is we only want to add one of those in if we actually have any grass blades in there. 1 second. mean, you should only do it when it actually touched a performance bottleneck. Yeah, exactly. That's what I think as well. Yeah. Unless you just want to do it kind of for fun. Yeah, exactly. Okay. So, what do we want to do? We want to add all of the grass blades that intersect this box. So array grass cell. So array grass cell cells. And we're going to go for auto source cell. Well, we'll call this dest cells. For in grass cells, I think. So does the cell have? What is the cell? Not there. Not that. The cell is a position. So we're going to go if box intersect source cell position. I'll add it in. The cells to add source cell. So here's the thing as well. Now that should be fine. I was just thinking that we might have cells. It's not round down really. It's not round down. It's so I don't want two cells to end. I want a cell to end up in multiple boxes. So it's not round down. It's how do I want to do this? Let's have a look at some more code. So in the game board editor, we're doing this with Windows round sprite location. Well, we are just doing round down there. I think what we do is we do BB is max x min plus tile size. I think it's that. Then they won't overlap. Okay, let's just run this and check. that's not right. It has to be that. It has to be round up because we're going to go through each individual tile. Now, if the cells don't overlap, I think this is fine. So if these boxes don't overlap, the cells can't end up in multiple boxes. Alright, so what we now want to do is we want to go, if not dest cells, continue. If we have dest cells, we want to add a sprite. So this, the sprite, so we can't do this append sprite anymore. Because the position is different. It's not the instance position anymore. So we can't go on brush tiles either now. So that's basically no good. So let's just copy this. So we can do this. That's fine. We can't really add a brush tile in though. We can do this, but this happens here. And can't do a brush tile now. So to be fair, we don't need any of that either. So what ID do we want? I think we want hash for instance ID XY. That's eSprite type grass, sprite kind, say normal. The position, is box XY. Origin is 0. Z-bias is that. That's fine. That's fine. Submeshes. That's fine. This needs to be. So this needs to be auto use sprite ID. Segment count we can actually add in directly now. And just add it in like that. So this segment count is S32. What's this segment count? S32. What's the problem? S32 to U32. U32 apparently. Might change that to S32. Is that gonna cause a problem? Do that for now. So what that does is it's going to generate sprites on a grid throughout the level. And as long as there's grass in that grid, that sprite gets added into the level. What we can also do is we can put local bounds in before room ID is box.width rect 2 box.width height like that. Okay. So now what we need to do on the texture generator, is basically, so the texture generator I think remains the same. Oh, there's no brush tile. So we do need to add a brush tile in as well, one for each of the grass content data. So we do need to do this. just return. Okay. So that will generate the actual, that will add in the texture to the tile book if we do that. Generate meshes needs to be different though. Anyway, let's just run this and just see what happens. So if we look at the level now, it's got 2 sprites in it. Two submeshes in it. And then we'll call generate textures. We're just appending an image tile in. So when we generate the meshes now, I think what we need is, well, let's just do the mesh generator for grass. So the brush tile in it, we might need like sprite range. In the brush tile. So tile range indices doesn't actually get set, does it? No, it does. It gets set on the texture generator. Yeah. So what we need is we need array size t. Well, or we could just do index range, sprite range. We'll try sprite range. So we want to do this. So we need wherever we get the sprites. Here. Is sprites get count. Sprites get count. And then we just want to plus the sprite range here. Last equals this. Okay. So get rid of them. When we do the mesh generator for it, should be able to get the sprites back out. At least. So what we need actually so the brush tile, it only added one sprite in there. Ooh, interesting. There's two sprites and they're both grass. They're the same type of grass. Zero, zero. Ah, it's +1. That's why. Okay. So the brush tile has in it now sprite range. So they're the two sprites. So what do we need? We need the actual positions as well. Of each cell. Or we do the test again. How do I want to do this then? There's two ways. We could either do the test again, this full test again, which seems a little overkill. Or we store the grass cells somewhere. So we could have like array of grass cell. Like that. Which means that for, you know, each index in here. So we could have something like struct grass section. Which has in it the index range, the sprite range, and it has an array of grass cells like this. And we could have an array of grass sections. Like that, maybe. So this would be grass sections. And place grass section. Do it after we've made the sprite. No, it's not there, is it? It's here. Here's theirs. I think it is here. Where do we want to make a grass section? So maybe it's not. Maybe it's just one sprite index. Where are we? So grass section. Like that. So this would be so there's no such thing as a sprite range anymore. It would be grass sections in place, grass section, sprite index, oh, hang on a second. Where do we add the sprite in? Sprites, so auto, sprite index, sprites, add, standard, move, new sprite. So the grass section sprite index is that, and the cells is dest cells. Okay, so by the time we get to generate the mesh, we should have some grass sections in there. Brush tile, grass sections, 2 grass sections, and they've both got cells in. And the cells have the positions. I think that is everything we need to generate this mesh. So, we want to get the sprites. And then we want to go for auto grass section and brush tile grass sections. The submesh so we need to get the submeshes as well. Here's submeshes, sprites, grass section, sprite index, dot submesh index. It's a bit of a mouthful. So that gets us the submesh. So that's basically what we need to set. So we'll see if this runs to here without crashing. Yeah. Right. So let's elevate these up here for now. So the vertices are the grass vertices. The range is 0 to 1 for the tile. So the submesh is literally just 1. The submesh index submesh range is just the vertex. So the submesh, the index range is equal to vertices get count, vertices get count plus 1. It's just 1 vertex in the submesh. And now we need to add that vertex in. Okay. BB. No, it's not. It's the number of it's grass section, cells, count. That's what it is. Because there's one grass section per sprite. So the index range for that is 0 to 30. They all share the same texture. So texture index 0. Okay. So I don't know about Rect World. Definitely need the UVs. 2 UVs. So we want to go for auto. What do we want to do? Like we. So the range count can only be 1, essentially. We're going to say if range is not equal to 1, I want to return so we'll say range index range.first. Range index, that's the texture index, that's the texture. This whole bounding box thing doesn't make much sense because it's only a point. Well, okay, it would be the sections bounding box. Alright, I'm going to take a 2-minute break and I'll come back and we'll finish this off. Break, 1-minute break. So this is the bounding box of the submesh index that we're working out here. So I think it's actually we go, the BB is just so we'll say with each grass section cells BB dot add arg position. I think that's it. And we don't do this stuff. So now we need to go through each cell. For auto cell grass section cells. We need to start adding the vertices in. So so how do we do append grass groups before? Where are we building the grass vertices? Is it in the tile set generator? No. Tile book generator. If it's grass, here we go. I guess I'm going to put this on this side just so I can have a reference. So we want the width, height in world. So we do actually need to do this. So we're going to do level grass vertex. Oh, auto V equals vertices fill with, and we want so we want auto cells, grass section cells, right? We'll do that to start with. Up here. And that can just be cells. I'm going to fill with cells, .get count. And then so we'll go 4, 2. It's offset really. V offset. offset plus cells. Get count. So we'll do cells, auto cell count. Thanks for the follow, Yui. Yui69. How's it going? Yeah, if you've got any questions, let us know. Working on a little bit, it's a bit complicated at the moment. Working on generating meshes for grass. Cell count. Okay, cell count. Cell count. So V is the index, the vertex index we need to fill now. Ooh, 1 second. So we need the dest tile. The dest tile. So we've got dest tiles of the range index. So it's a dest tile F. This is the range index. Wherever we see I is the range index. I think. Tile ranges of the range index. Tile ranges, range first. I think it's that actually. That returns an index range. Dot first. It's only one tile. No, it's not. But we're doing tile ranges. Brush tile, tile range indices 0. So that's not, I think it's just that actually. So this is range index. Right, so we have our UV for each cell. So now we can go vertices V, UV0 is UV top left. Vertices V, UV1 equals UV top right. And then we're changing this. So let's just put the last one in. Texture index. Texture index. Vertices V, width height world is rect world. Well, it's just a source tile F. Well, it's just rect world width height So what we actually want to do here is put in a position now. Like that. Which is vertices v dot position is equal to the cell position, which we don't know what it is. I think it's just cells offset minus v, or v minus offset position. I think that's it. And that builds the mesh. So let's have a quick scan through that. Let's see what happens there. So it's kind of changed. Ooh, what's happened there? There we go. So we're changing the way actually in the game now we're going to draw grass, because we're providing a position which we weren't doing before. This is unbelievably complicated. So what I'm going to do is I'm going to go width height world is just source tile. So width height times the inverse pixels per world unit. And that's just width height world. And just scan through this and just see what's going to happen. So what we're ending up with now is a section of grass which is 8 by 8 world units. And then in that section there's a mesh, which is just a bunch of positions really. And then we can look at that section. We can colour it if it's not on screen. And we can call grasses, like the grass, section by section.
Ads running soon.
Right. There we go. That builds our grass vertices. Not going to see anything. We've seen some little dots. So they're the actual sprites. They're actual sections. Okay. Okay, so in the level generator, level data generator for grass, we need to translate it. Bamberg, how's it going? Hope you're alright. So what do we want this? We want this relative to the instance position. So I think that's fine. I think that's fine. It's not going well. Oh no. How's it? What's happening? Okay, so the game level. Room. So we're in the game now. This will all get rewritten. But we can work with it. Oh no. Can't implement what you want. You have the right brain. Good thing about brains is they can be drained. So the sprite local bounds has not been set properly. So what's going on there? Submesh bounds. Where are we? Framed animation. We're in the wrong one. So the mesh generator for grass. The submesh bounds should be being set there. So submesh bounds equals the bounding box. Right, let's try that now. What are you trying to implement then? There we go. So I believe that is actually... What is that? It seems wrong. It's the bounds... of all of the cells. I think that seems wrong. It seems wrong. It's the grass section bounds. Okay, so grass sections probably need a bounds. And then on the level data generator, when we actually generate these grass sections, just the box. Okay. So the submesh bounds maybe we don't need to do that there. So we could say new sprite dot local bounds dot what would it be? Submeshes new sprite submesh index bounds is the box. Like that. So we don't actually have to store it in grass sections. I think. I'm lacking the ability to think abstract. Ah, right. Riddle with bugs. If you want to describe the problem, I'll try and help you out. If I can. Okay, we need to make sure it goes through the level editor, the level generator code first. Okay, that didn't work. Why didn't that work? Oh, because we're still setting the bounds. We don't actually want to do that now. So the submeshes should have bounds in them. Yeah, that was correct. The weird thing is that is the grass that we're trying to compile down. So that bounds there should be here. What's going on there then? Naught to 24. -8 to +8. X is -8 naught. So the box is -8 naught and the width and height is 8. That seems correct. New sprite position. Ah, okay. It's because it's local to here, so it's actually new sprite.local bounds. There we go. So there are two sprites, which is going to hold the grass data. It should be there. We're just not rendering it. So, game level. If type is grass, it's vertex dot position plus sprite dot position. Oh, done the wrong one there. Segment count, so it's vertex dot position plus sprite position. And that's the same there. Well, the Z, yeah, that's the same there as well. Plus sprite origin. I don't think that is right though. So we're not seeing any grass. So 0 to 30, grass vertex. Okay, so what's going on there then? To pix this out, to do this with pix, I think. Most likely, UV is wrong, but we will see. It's this 60, I think. Let's have a look at the wireframe of that. Yeah, they're all there. They're kind of not in the right position though. But they're all there. What is the texture? There it is. Interestingly, the textures... Oh, well, I think that's because it's not central, but that's probably because it's got to be a minimum of 256 pixels wide. Okay, so what's going on there? Why is it coming out black? Or it coming out nothing? Likely UV. It's likely UV is the problem. All the wrong texture. Let's have a quick look then. Okay, so grass. Let's just return from the vertex shader 1. Oh, what's going on there then? What's saying there then? If the shaders in the string, so it's returned the file name, not the path. Weirdly. That's weird. I think that worth investigating. I did do some work on the hot loading. So obviously this now is broken. Is it read directory changes? Try that. Oh no, don't give up. Let me try and help you if I can. So for some reason now, it's not returning the... This is so broken. It's not returning the directory. It's a lot of stuff. So look, it's not returned the actual directory. It's just returned the file. That's so strange, man. Why is it not return the directory? Or the full path rather than just the file name? Okay, so we need to make sure basically if it's not the full path, it needs to actually add on the HLSL directory. So we're going to say if path.length is 0, path equals helpers format TW string. HLSL directory. What happens there? Just my own judgment. Trying to build. Yeah. It's okay to ask for help as well. Ooh, hasn't actually appended on the path. Okay, that's a bit of a bug. Let's change. Okay, you can see the grass there. Hang on, let's just fix this first. Okay. Okay, so now it's the full path. So it goes get file name without extension. So it doesn't actually even need the to do that. So this could just be change. Depends if this include file. What's the problem here then? Path. Depends if these include files here. It's doing a direct check. So it depends if the include file is just a file name or not. So let's just try and change a header file. Okay, so that has to we have to append shaders on. Okay. So this is just shaders. Like that, sorry. So that's backward. That's also backward slash there. So the include files there. Where do they get set? In the compiler. So include handler files. What's the include handler? Relative path. I'm going to do path use forward slashes. How do we do it? In the other way. There. So let's rebuild all the shaders. Rebuild the build tool. Fine. Rebuild all the shaders. Rebuild all of them. Oh, interestingly, that triggered a big rebuild. Why that is. I wonder if we've got some incorrect dependencies there. Where would that be? Build dependencies. Build tool. Build tool. Build dependencies. I think we'll just do that. For now. So if I rebuild the shaders, it rebuilds the build tool. I don't want to do that. If I rebuild, so build dependencies. Where is it? I'm going to take that off. Okay. Try that. Okay. So now let's change this header file again and check we're actually checking with the right include file. It's plumbing still backslashed. Why is that the case? Include handler. What's going on there then? So let's rebuild the graphics. And then let's rebuild the build tool. And let's rebuild the shaders. Obviously doing it in the wrong place. Okay. Build reflection.
Ads running soon.
Include handler files. So let's set a startup. Let's see what happens here. Reflection. They are the right way around. So what's going on then? Why isn't when we set this to start up? I don't understand. Where does DX shaders come from? Reload shaders. Shaders. So this is probably in. Okay, yeah. Get the. So we're packing them into the LST. LST is just like basically the library of all the assets in the game. So what I'm going to do is delete all the shader groups. And then build the shaders. There we go. That worked. So now I'll do this. That's working. Good. So here's a thing as well. So the grass is there. We're just not, there's no colour or anything. Let's have a look at the texture coordinates. UV, UV, 1, 1. That kind of seems wrong to me. There's no green, means there's no Y texture coordinate. Okay. Let's have a look at this, how the texture coordinates are getting generated. Mesh generator, grass. So these UVs here. $180, 296 apparently. Okay. The desk tile. $180, 296. It's 256 by 300. Top left, probably bottom right as well. Could be a typo. That seems better. That seems better. So let's have a look at the grass shader. Ah, there we go. There's some grass. Okay, so they're obviously in the wrong position to start with. Because we're meant to be doing this. They're in some wrong X locations going on. Y looks good. The cells positions. Ah, yeah, so it's not the sprite position. When we're actually drawing the grass here, we're incrementing the sprite position. We don't actually want to do this, but we do want an offset, some kind of offset. Because we want to be able to like move them if we want, like the whole tile. Okay. So they're in a lump now. They are slightly wrong on X. So it must be minus the origin. Minus instance. So that is the position that is, yeah, the position is, the position is the position. We actually need, well, to render them at minus the origin. So the origin, instance, not origin. We do have width height world there. Let's try that. I don't think that's kind of right though. Because it's a point, the vertices are points. So it is drawing right. But I shouldn't have to subtract the origin. I don't think. It's either wrong, we're doing something wrong building this, or we're doing something wrong compiling it. So let's just do canvas or quad. For quad in world vertex dot position dot inflate. So we'll just draw some quads at the vertex position. So the vertex position needs to be at the base of the grass. Yeah, it is. It's at the base of individual grass blades. So to just test that, what I might do is move one over here. You can see there, yeah. So that is correct. The position is correct. So it's the way we're building them. So it could be in the shaders. No, I think we actually do build it out. We don't build it out by inflating like that. We build it out by inflating like that. That's probably what it is. So this actually needs the origin. Which one is it? There's a bunch of them. Texture segment, texture color. So how are we doing this in the editor? And game board content. Renderer for grass. Cell position plus P. P minus is the origin. So many. I think for all of these, we're going to pass in the origin. All the grass ones. And that's position minus origin. A lot of different ways to draw grass. E. So that's instance origin. So that is this. No. Cell position. Cell. Whoops. Instance origin. P. So that's cell position plus offset. Yeah. Cell position plus offset. there as well. Getting all these PDB problems now. So this is Sprite Origin. So where are we now in the sprite sheet editor? Tile. Does it sell? Need to know the origin. Grass. I'll just say vec20 there. Where are we now? Game board editor. Alright, so this is instance origin. Instance origin. And there. Alright, let's see if we've broken anything. Oh, immediate crash. That's not me though. That is something that's just not built properly. Alright, cool. Let's see then. That was good. That was really good. That's good. That's good. Brill. So now what I want to do... So these are obviously... So these are the tile bounds, right? But obviously if I'm going to use these to cull the grass, it needs to take into account the... you know, the grass can... It starts at a point, but it can extend up. So this is not quite right for all the bounds. So we'll work on that now. Well, we'll have a break. Getting all these errors. We'll have a break, then I will do that. So I'll be back in 2 minutes. Okie dokes. Right, so these are actually the sprite tiles, but they're not the sprite bounds. These are just the way I've divided up the origins of the grass, which are these little white rectangles here, because the grasses just start from a point and then they're built on the GPU. So the CPU only really knows about these origins. So what we need to do is put in a proper bounding box for them. So that is in here. So here we're just saying the bounds is the new sprite local bounds, which is not correct. Neither of these are correct. It just depends if we're using these later on down the pipe. The texture generator for grass doesn't use it. The mesh generator for grass it doesn't use it. So I think we can say that the actual bounds, so the submesh bounds is so it can go bounding rect BB, and it would be BB dot add rect vertices V dot position minus some origin, which we don't know what it is. What's the origin then? Do we have the sprite? We have sprites. We do have the sprite. Sprite, grass section, sprite index. So the origin is the sprite, the origin, and that's width height world. And then we want to do submesh dot local bounds is BB get rect translate by this minus the sprite position, possibly. That might actually be local actually. So we might not need to do that. Let's try doing it without doing that first. See what that looks like. Kind of wrong. Let's do vertices position. That's wrong. What's going on there? Let's check we're actually running through here.
Ants running C.
We are. So what's width height world? Width height world is obviously wrong. It's the source tiles width height. Try that again. So it's 9 in height. Seems about right. That seems right to me. Cell position -8 in X. 1 in Y. So it's going -8 to +5. So they just look completely, that's not right, is it? -8, 1, 2, 3, 4, 5, 6, 7, 8 is there to +5. What's going on there? Confused by that. So there's the submesh bounds. Let's go to finish. So we've got 2 sprites. Sprite, first one, a local bounds. It's 0, 0 for some reason. Oh no. We want the submesh bounds. That's what we're transferring over. -8. So that seems alright. Ah, right. It's because it's not local. Okay. It's not local. Translate -sprite dot position. See what that does. Okay, that seems good. They do seem a little bit overlappy. I wonder why that is. So we do have to minus the origin as well. What's going on with all these error messages all of a sudden? All these PDB error messages, I'm not sure. Okay, that's better. That's better. So, if we do something like this, we go some there, some over here. So now it gives me rectangles I can cull, basically. And they are overlapping, but that's fine. So if I don't want to draw, so I can basically test that the camera is over the top of them. So how many sprites did that generate? Sprites. Seems to be working. Let's add more stuff in. Let's put in some floor. Let's add a new layer. Floor like this. Whoops. And then let's put in, make a new layer. Props. So definitely a Z problem there. Figure that out. We'll do that next. It's right on the preview, it's wrong on the render. Right. Seems right to me. Bit confusing to look at. Cool. Okay. Good. And let's check also the pics. Let's check the draw calls. Quite a few draw calls there. Well, not really. There's like 10. There's all the ground. Some grass. Flag. More grass. But the grass really does space out the draw calls. And that's the texture. Don't really know what. Can't remember how we got all the text, all the mesh to show up before. Oh well. So it's a 4K wide texture it generated. Just one of them. I don't think there's any duplicates there. Which is awesome. Okay. Okay, so what's the last? What is the last thing? What is the next thing? Oh yeah, I wanted to sort out what's going on with the Z coordinate for this thing here. So that's on the grass layer. We need a way to actually move things onto different layers. Don't have to, currently can't do that. That's on the grass layer as well. All get put on the grass layer. Alright, so that's correct. The preview. When I stamp it, it goes behind. So it's the drawing when it's in the level. Okay, so got minus origin there for the position. Instance position plus offset. So I think so P saying minus instance origin, but then we're passing instance origin in. Okay, so what we need to do then is this is not actually minus instance origin. This is position minus origin. And this is also position minus origin. So now that is just position Y. And that is just position Y. So there's no origin there anymore, we're just passing it in. And then in the preview, so what's that? Game board editor. We want to preview stamping cloth. It just goes to normal. What does normal do? Stamp normal preview. Again, it's doing the origin thing. So draw texture in world. I think it's like this. Paintbrush position. Brush origin. Draw texture in world. Is position minus origin. Position. It's that. To get this right, really. Lighting draw. Brush lighting draw. All right, let's check this in. Draw light texture in world. I think we're gonna have origins for all these, you know. So what's this? P. So P is local offset. So this is brush origin. So we also want to do it with the glow texture. All these PDB problems. What is going on? No idea. So that's brush origin. P. No P anymore. Paintbrush position. P. Yeah, interesting. So I think we take off origin there as well. We take away P in general. And this is brush origin. Draw scaled texture in world. And this is brush origin. So this is paintbrush position. So we've got draw lighting for trees. Okay. There's no lighting for trees at the moment, but I guess we can leave a little hole in case we want to light it later. PDB, Li-Fi Gardener PDB was not found. It's not copying PDBs over anymore. Strange. Okay. So there's no origin anymore. Makes it a bit simpler actually. Draw light texture in world. So that's origin. That's origin. Light. So draw light texture in world. So we're in game level. We need to get to this. So I don't know what we're going to do there. Draw light sprites. So where's the origin?
It's been a while since I left. Nobody knows where I went. But I think I found my
There's a light file. Doesn't have the origin in it.
Don't worry, I'm doing just fine.
Um,
In the islands where the time
position. Oh, we have origin. Look.
on my pace. I've been
Ooh, what's going on there? Went back to the wrong place there.
It don't matter if I'm lost because I know when I'm with you,
Draw light sprites.
when I'm with you, I'm just riding waves 'cause I know
I think that's just Vec20.
where the tide goes. The sun is on my face. Searching for treasures in my mind. I know I'll find it 'cause the islands are showing me the way. I've been floating coast to coast.
And all these errors, like
Cuba to Mexico.
things not building properly.
It don't matter if I'm lost because I know.
Just crashing this. So this crash here, it hasn't even got to main yet. So it's not my code. It hasn't even got to main. Calling main.
It don't matter if I'm lost because I know. It don't matter if I'm lost because I know. When I'm with you, I'm home.
Right. So we're back in. I want to check some stuff that we changed. So we have an undo problem there. We regenerate the light. Okay, I'm gonna write that down. I'm not gonna try and do that yet. Got both of those fixed. Generate, undo, redo. Or generate lighting. Doesn't work. Right, so what I want to do is why can't I move while I'm doing that? Oh, wrong selection layer. Okay. So was it, so the origin for the little crypt thing is right where the mouse is. So when that passes under the origin, and the origin obviously for the cloth is where the mouse is. So when I pass over the origin, so it's above the crypt, it's over the origin, goes below it. That's correct. That's correct behavior. It's very hard to see actually. Let's just put, oh, interesting. That's a little bug as well, because those are filled in there. Those little red squares, so they're the anchor points for the cloth. That's just under, so that hasn't worked. So that one is just that one's under. That one's just under. And it renders just under. Just under. Maybe it does work. That doesn't work. What is going on there? Alright, see what's happened. Oh, so when a save here goes under. That's very strange. Just under. Stamp it. It's very under there. When a save here goes under. What's going on there? Okay. So when we're rendering the cloth now, we're doing Z 113. Seems right. So what I need to do, we'll start. We'll delete all that again, and then we'll just do a cloth and a sprite sheet tile. So we'll do this one. Add a new layer. And then we'll add cloth now. Try and get it to be. Okay. So this Z is -32. The normal one, which is the crypt thing, is -32. Right, so it's because of the same. Alright, so if they're the same, we can't flip the order, which I don't think we do. Okay, that's in the canvas, and we do sort and batch. So we're doing stable sort there. So it shouldn't flip the order if they're the same. I believe that's the definition of a stable sort, or one of the ways you can use it. Okay, and this is now drawing wrong. That's probably fine. It's because we're subtracting the origin in the wrong place. So game level, take room. Alright, so that's in the font level generator actually. It's a mesh generator. It's probably there. There we go. So it's drawn it in the right place. The bounds are not in the right place. So submesh bounds. Only for cloth though. Sprite.local bounds. Translate sprite.position. That puts the local bounds into position. So the local bounds cloth bounds dot translate by minus sprite origin. I think. Nope. Check, it actually goes through the builder, the level generator. It's minus sprite dot position plus sprite origin, I think, actually. What's going on there then? Submesh bounds. What were we doing before? Brush tile, brush origin. I wonder if it's because it's regenerating it from the rest P. I think what it is. So it's going to regenerate it from the rest. It's going to regenerate the submesh bounds from the rest position. Probably. So we literally just need to minus the origin off the rest P. We have to be, probably has to be a minus equals. Let's try that. Is that what we had before? Yeah. So this is, it's the other way then. So the game level. I think there is no origin because the origin is built into the vertices. Nope. Okay, that's the wrong one anyway. I think the origin is actually built into the verts. The minus origin. Yeah. Not there though. So can we not have both? Is this the problem? So the editor is now drawing it in the wrong place. Okay, so it must mean it's because the origin's built into the actual cloth mesh. It's a bit confusing that. So this is the situation now where we've got the same Z. Minus 32. And the normal one is also minus 32. So for some reason it's swapping them. Which canvas is this? Editor left canvas, right, tab, board. So that's 96 of them. So minus 32, imaging world, mesh. So the mesh one must be the cloth. Now it's left them. So when I save, oh, now it's fine. Oh man, this is annoying. What's going on there then? It's because it's. You just basically don't have enough Z resolution there. I can change the Z resolution. Z resolution is 32 levels per world unit. I think. So it's quite high resolution. Alright, I need to up here in location, I just need to location. I just need to output the Z. Z is canvas, Z, paintbrush position. What's with all these warnings about PDBs? Just started, literally done nothing. I don't know. All right. So now if I select it, so it's because I think it's drawing. It's the fact that it's drawing the preview. Is it drawing the preview before the level? Before it's drawn the actual level? And then we add the cloth onto the end, and then it draws. So it's going, right now it's going cloth, then tomb thing. But when I stamp it in, it's going tomb thing, then cloth. And because they have the same Z of -32, it's drawing it over the top. I need to fix that. So basically the preview has to be drawn last. Content draw there. Has to be done there. See if that fixes it. Go back to -32 now. So -33, it should go below. Yeah. So -32. So that would be drawing underneath before. There we go. Awesome. Don't have energy. Might have COVID. Maybe. Yeah, take some rest. Alright, so let's just now practice. Let's just draw some grass on. We've changed a few things about Z order now, so I want to make sure is working. There's a lot of grass. That seems good though. So then if we wanted the flag to be in front of the crypt thing, we'd have to change the Z bias. That is actually working. Not of that though, of this one. Awesome. Frustrated at the same time. Maybe need a break, I would say. Right. So let's put in another layer. Minus 10,000, brushing in some floor. Ooh, that's broken. Super broken. So broken, man. What's going on there then? Alright, let's just do floor on its own. Hopefully it's still broken. So I've done that. It is broken. How have I broken that now? So game bar content, sprite window content, render sprite window. That's concerning. So how is that broken? What have I done to break that? First things first, do a rebuild. I haven't really been working on that code. What is going on? 14 masks. I've apparently really broken it. Let's have a look. The test room has no alpha masks. If I save it, what happens? It generates a few alpha masks. Oh, man, why can't I see the thumbnail? View. Oh. Where is it? Always show icons.
Ads running soon.
So Luke. Really bad, man. Should be able to view TGA files, thumbnails. Open the File Explorer and click the 3 horizontal dots. In the folder options, view. Always show icons. It's unchecked. Well, Sage Thumbs. I thought I had Sage Thumbs installed. Sage Thumbs download. Set up. Well, it's definitely not the right amount of image files for sure. Completely broken this, man. No idea why. Game board editor. So it's the content painter. You haven't looked at a content painter for ages. For brushing sprite windows. Where are we? Content painter, brush. For brushing sprite windows. Where is it? Oh, let's have a look at sprite window. There it is. Alright, I've installed. There we go. Yeah, that's just completely wrong. That's completely wrong. So let's have a quick look at what's going on there. There's 17 masks. Why is this broken? What did I do? It's definitely not 17. Okay, now it's working. No, it's not working. It's flickering. Masks is empty. So it makes a mask. Places content. Alright. So what I'm going to do is just stamp one. So there's a mask. In the game bar content, the renderer for sprite window. I only got 10 masks. Mask image, mask path. Test alpha masks. Right, so what's going on there? I'm going to save that and then we're going to check there's no alpha. So there's no brushes at all in there. So I'm going to do just one. Put 4 masks in. That's possibly it can put 4 masks in. Strange bugs, man. Something to do with content cache by the looks of it. So this place content. So let's make it much smaller. .847 is a lookup ID, so it puts it in fine. And then we're just going to write the image to the disk. Is that right? No. I'm going to create the image. That's what we're going to do. Okay. So we should have something in there. We should have one in the content cache now. Yeah, it's because for some reason the content cache is not able to get it out. So we're looking for an image. So when we placed it in the cache as an image, so it should be there. There's nothing in there, nothing in the images. Okay, so the place just didn't work. Try that again then, let's have a look, see why the place didn't work. So the asset type is image. We call append asset. So we're in image base now. Let's break when value changes. Okay, so it's immediately destroying it. What's going on there then? It's placing it in and then immediately destroying it. Okay, well, at least that's something we can check. What have I done wrong, eh? Alright. So we'll do back to place content. And then what it should do is it should mark it as never grow old. So end asset. Never grows old. So the last used frame is this, which is like infinite time in the future. And then the container tick. Wherever that is. So here we are. Oh look, frame count now. So that is not working. Is old. Oh, I don't know what's going on here. No. So we threw a breakpoint on place content. Yes. Okay. So place content is being marked as never grow old. So the last used frame is enormous. Desk is old. If it's not old, we'll continue. So it's saying it's old. So the frame plus 1024. So it's looping over. That's bizarre how that's never been a problem before. So that's minus 1024 like that. That's what it's meant to be. Right, let's try that again then. Why is that just shown itself now? That should have always been the case. There we go. That should have always been the case. Still broken though. That worked. We might be fixed. With that is bizarre though. That never actually was a problem before. Try again, make sure we are fixed. No, we're not. Now we are. What's going on then? Now it's working fine. Right, well, we need to get it to a state where it's broken. Okay, now it's broken. So what happened there? Again, there's no mask path. This content cache is messing up. Alright, so I'll get to here, put a breakpoint there. once. Now it's working fine. Oh. Okay, what's this one? Last used frame. Alright, so something's updating last used frame. So what we need to do, I think possibly use, so if never grows old, or if not never grows old, so it grows old, do that. Shouldn't be updating the last used frame. Not equal to that. Let's see if that causes a problem. Shouldn't be evicting any of these from the cache. We're getting evicted from the cache, that's the problem, that's why it's causing this problem. There we go. No idea why that hasn't been a bug all this time. Oh. Just disappeared there. It's okay now though. Did it all just disappear? Seems alright. Let's try again. Random bug that. Look, it's evicting something there. What is it evicting? Last used frame. How does that get there? The last used frame's enormous. Okay. If, let's say frame count is greater than 1024. That might be a problem. Might be rolling under now. Check we've got this breakpoint set. Yeah, that's good. Try one more time and then we'll just call it sorted, I think. Seems fine. Seems fine now. Alright, cool, cool. Check that in. That was a pretty nasty bug. Alright. Ooh, look, it's trying to do it. Oh, this is a brush file. Yeah, this is alright. This is allowed to go out. That is allowed to go out of the cache, I think. Is it allowed to go out of the cache? Are brush files allowed to go out of the cache? Yeah, I think so. Maybe. Should we say if it's loaded at startup? Where is this? If it's a type that's loaded at startup, maybe it isn't allowed to go out of the cache. We can say else if context bar not set loaded at is loaded at startup type. Let's get rid of some of these brackets.
Ads running soon.
Awesome. So we're not going to allow anything that's loaded at startup to be evicted from the cache. I think that's the best thing to do. Alright, so what I'm going to do is just do a quick level of everything. We've got like 10 more minutes. We'll do a quick level, complicated level of everything we've got working. So I'm going to call this floor. So we'll do this, and then we'll do this. And then we'll do that one as well. And then we'll put in one of these on top of it. Different layer though, props. So definitely when we make a new layer, it should swap to it. And then we'll do something from a different sprite sheet. Like we'll put in some of these barrels. And then we're putting some cloth. I don't know. Maybe there. And then some grass around the cloth. And we'll do 2 different types of grass. We'll do that. And then we'll do that one as well. And then in front of everything, we'll do the framed animation. I think that's one of everything. Let's see if that loads. That seems good. And then what we'll do is we'll just get rid of these bounding boxes for a second. These ones as well. Then we need to figure out why we're getting all of these linker warnings for the PDB files. Just started appearing. So, question is, does everything look in the right order? Oops. Colours are, like I say, slightly muted on here. But that's okay. Looks good to me. Get in there now. So we did grass today. Tomorrow is probably... What other ones have we got to do? That are from the sprite sheet or trees. Put a tree in. We should be more straightforward, he says. That was good. And then we need to do lighting at some point. Lighting needs a pass because it's not working in the level editor or the game at the moment. And the shadows. That'll come. Alright, I'm done for the day. Back on. Hopefully, what is it today? Wednesday. Back on tomorrow, hopefully. I'll see you later.